Every meaningful action begins with a decision. And when you strip it down, decisions are really just sequences of tokens that make sense together. Our brains are, in a way, biological token-generating engines. Large language models, or LLMs, aim to imitate exactly that. Imagine you're driving a car. Suddenly, an elderly person steps onto the road unexpectedly. Your brain instantly processes the context and outputs the correct token: apply brakes. You definitely don't think reduce music volume or adjust mirror. You know the context. But here's the catch. A raw, trained doesn't actually choose actions like you do. It simply lists possible next tokens and assigns them raw scores based on its training data. These raw scores are called logits. A logit is an unscaled, raw numerical prediction. It tells us how strongly the model associates a token with the current sequence. If a sequence appeared frequently in the model's training data, its logit will be high. For example, if you trained your model exclusively on a database of car accident reports, the model might see a car on the road and generate the token use mobile with a very high logit, because that's the pattern it learned. But logits are just messy numbers. They can be negative, they can be huge, and they don't add up to 100%. We can't roll a dice on them yet. We need a system to convert these messy logits into a probability distribution, a list of percentages that add up to 1. We need the Softmax. Here is the standard formula. Let's walk through this with numbers. Imagine the model has 3 options for the next action. Option A, brake, with a logit score of 2.0. Option B, honk, with a logit score of 1.0. And option C, radio, with a logit score of 0.1. Step 1. We calculate the exponential of each logit. That means we take the constant e, which is approximately 2.718, to the power of the logit. For brake, e to the power of 2.0 is about 7.39. For honk, e to the power of 1.0 is about 2.72. For radio, e to the power of 0.1 is about 1.1. Notice how the gap got bigger? The exponential function widens the difference between the top score and the others. Step 2. We sum them up. 7.39 plus 2.72 plus 1.1 equals 11.21. Step 3. Divide each exponential by that sum to get the probability. For brake, 7.39 divided by 11.21 is 0.66, or 66%. For honk, 2.72 divided by 11.21 is 0.24, or 24%. And radio comes out to 10%. If you sum these up, you get exactly 1. Now, the system rolls a dice based on these odds. It won't choose the highest probability every single time. Sometimes it might choose honk, but brake will be chosen most of the time. Without Softmax, models couldn't decide anything. Softmax is the bridge between raw predictions and meaningful decisions. Now, we can manipulate this bridge using hyperparameters. The first and most famous is temperature. When we add temperature, the formula changes. We divide the logit by the temperature before doing the exponential math. Let's see what happens to our brake and honk example. Scenario A, low temperature. Let's set temperature to 0.5. We divide the logits by 0.5. Brake, 2.0 divided by 0.5 equals 4. Honk, 1.0 divided by 0.5 equals 2. Now calculate the exponential. E to the power of 4 is 54.6. E to the power of 2 is only 7.4. The gap is massive. The probability of brake shoots up to nearly 90% from previous 66%. So, the model will choose brake more times than the normal case. Use this when you want the model to be deterministic, accurate, and focused. Scenario B, high temperature. Let's set temperature to 2.0. We divide the logits by 2.0. Brake, 2.0 divided by 2.0 equals 1. Honk, 1.0 divided by 2.0 equals 0.5. Now calculate the exponential. E to the power of 1 is 2.7. E to the power of 0.5 is 1.6. The numbers are much closer together. The the probability distribution flattens out. Honk and radio actually have a fighting chance now. Use this when you want the model to be creative, surprising, or random. It is enough math for one video, but we're just started. Here are some of other hyperparameters and their corresponding formulas. Please comment if you want an explanatory video about these parameters too. Do a thumbs up if you find this video helpful and subscribe to our channel for more such videos. Also, please comment if you want any changes in the style of explanation. Thank you for watching.